So once you have installed OpenDNSSEC, whether it's from source code or from a pre-built package, then it's time to start configure the system before you can run and sign your zone. And first of all, you have to configure your HSM. And I can only show you how to do it with soft HSM. And it's really straightforward to how to configure soft HSM. First of all, you have to edit the configuration file, which specifies which slots you're going to use and where it can store its information for each token. Meaning that you specify a integer, for instance 0, or if you want to have a slot 3, then you just write 3. And then a path to just a path somewhere in your system where you can write the file. So you have to have the correct privileges to create this file. But soft HSM will create this file for you, so you don't have to create it. Just provide a path where soft HSM can create this file. And the reason why I'm using this convention with a slot number and a path to a database is because, as I mentioned, in PKCS11 you have you use something that's called a slot and a token. And I can, for instance, say that a slot is a smart card reader and a token is a smart card. And the slot is always there, but you have, for instance, the slot 0, which is now our smart card reader. And then we have our token that we insert into the slot. And that is what you're doing with these two lines, or this line, but with the two options. And then the database becomes the token. But you can always move the token around and, for instance, place a 1 in front of this. So it can move around. And you can always do a copy and move it into another system. So you move the token over to another server. And OpenDNSSEC wants the token to be initialized because that's something that you have to do, and OpenDNSSEC won't do it for you. You can do initialization of the token using PKCS11, but most vendors do provide their own tools to initialize the token for you. So that is why we also have a command line utility named soft HSM. And then you tell it, initialize the token at slot 0, since we wrote slot 0 in the configuration file. We use the same slot here. And then we also give it a label, and this label is important to remember, because that is what's used by OpenDNSSEC to identify the HSM. That's the only thing that you can see in the PKCS11, that you can give to a token and you know that this is the token that I wanted. So you have to remember that you don't create multiple tokens with the same label, because then OpenDNSSEC cannot find the correct token for you. And the label is at maximum 32 characters long. And once you have this label, then you give it to OpenDNSSEC, and then it can find the correct repository for you. And I will show you then during the demonstration on how to do this, so you can see it once more again. But once you have your HSM up and running, you verify that it works as it should, then it's time to jump into the different configuration files that you can find in OpenDNSSEC. First, we have the conf XML, which gives you the overall configuration of OpenDNSSEC. It gives you the paths to the other configuration files, but also what the privileges the processes should run under, and also about logging, etc. Then you have your CASP file, where you specify your policy that will be used in the system. You have your zone list, where you can find the zones that you're going to sign with OpenDNSSEC. And the zone list also points to what policy to be used for this particular zone. And if you want to fetch your zone using AXFR, then you just configure the ZOMfetch.xml, and then OpenDNSSEC will fetch this zone for you and place it in the correct location where OpenDNSSEC can find it. see. Can you see this? Yeah, probably should change the colors on it so it's a little bit clearer. So we have the top configuration file is the conf XML, and then just points out the other configuration files. And you can always rename them to whatever you want. They don't have to be named CASP XML, but since we're just pointing out a file that should contain the policy. But before we jump into the configuration files, I have to mention the duration formats that we use in OpenDNSSEC, because we're always talking about roll the key each month. We want to have a signature that's valid for 7 days, or we have a TTL of 1 hour, etc. So you have different time formats that you want to specify. And then we use this standard convention from, I think it's a ISO standard, on how to write a duration. So first of all, you specify year, month, and day with a P in front of it, and then just the number of each of them. And if you want to specify time, then you write a T, and then you have hours, minutes, and seconds. So for instance, you can see here that we have 1 day and 12 hours is P1 for 1 day, or 1D is for 1 day, then 12H for 12 hours. But since we are converting everything into seconds for OpenDNSSEC, and 1 year is not exactly the same amount of seconds, because we have leap years, and the months also varies. But in OpenDNSSEC we say that 1 month is 31 days. So that means if you specify that keys are going to be rolled each month, then it's not exactly 1 month, because we're converting it to 31 days, which means if you're in February, if you start to sign the 1st of February and have 1 month, then we'll add 31 days, which means that the next key rollover will be the 2nd of February instead of, or perhaps the 3rd of February. And the same goes with 1 year. So if you say 1 year and start the 1st of January, and then you have a leap year, then you will roll the key the 31st of December. But I will come back about this and how you can, if you want to be able to roll at a specific date, and how you can do it. But do you understand this format on how to specify durations? Good. And first of all, we have the conf.xml. But in the beginning, since we're writing XML, I will just show you what you can find in XML files. In the beginning, we're just specifying what XML versions we're running and what encoding of the file is. And then we also have some stuff that we use in our Subversion repository in order to keep track of the files. So these signs, or everything between this sign and this sign, is just a comment, which is ignored by the system when it parses the file. So you can always write your own comments by using the exclamation marks. But then we have the important parts of the conf XML, and we have divided it up into different parts. First of all, you specify the HSMs that you're going to use, so that we have the paths to the libraries that the HSMs want us to use. Then we have some common part, which have, for instance, I think it's logging. It's also the paths to the CASP XML, zone list, and the ZOMfetcher. Then we have some information for the enforcer, signer, and auditor. And for all of them, they have you can run them under different privileges. But you can also configure, for instance, that the signer should use 8 workers, which means that we can handle 8 zones simultaneously, but the others will, if we have more zones than 8 that won't be signed, then they are queued up and will be signed once those 8 are finished. So let's see how it looks. So the first part was this repository list. And there you can specify, first of all, a name that you're going to use. So you name your repository to something, for instance, soft HSM. And this is what you use as a reference in the CASP or your policy later on, because you want to say that I want to create my case in this repository, but I want to create the status case in another repository. And this is the name that you want to use. So don't confuse this with the token label. The repository name is something that you use internally within OpenDNSSEC. But the token label is the same one as you specified when you created your token from the first beginning. Here you said my token, so you should write my token here in the token label. And this is how OpenDNSSEC can find the correct token for you. You might argue that you can make a difference between the HSMs used based on the module or the library, but you can have multiple tokens within the same library. So for instance, you can have 3 tokens in soft HSM. Then that is why we have to use the token label. And in order for us to do signing, we also need the PIN code to be able to access the HSM. So then you write the PIN code in here. But this is only the user PIN code. You also have a security officer PIN code which you use for administration of the HSM. Oh yeah, I think I forgot to mention that when you run this command, you're asked to input what PIN code you want for the security officer and what PIN code you want for the user. And then you also have the option. You have 2 optional parts here. The first one is the capacity, meaning that, for instance, if you have an HSM that's limited to 1,000 objects, then OpenDNSSEC won't create more than 1,000 objects. And this is a soft limit in order for OpenDNSSEC to quit gracefully or give you a nice warning message, because in PKCS 11 there's nothing to signal back to the application that now it's full. It will just give some general error back, and then it's hard to find out what the problem is. But if you set this soft limit, then you will get a better error message that your HSM is now full. Please remove all keys or add a new HSM to your system. The second optional part is the require backup. And some systems do automatically backups of the keys, for instance, do the synchronizations between your different sites. Then you can just let OpenDNSSEC run without having to think about backups, because everything is always backed up. But if you don't have that, or if you have some automatic cron job that runs every 12 hours, then you can add this require backups. And this will make OpenDNSSEC not to roll over to a case K or status K that has not been backed up. Because you don't want to start assigning your zone if you're using a key that hasn't been backed up, because what if you lose the key? Then you have a signed zone, and you have no way to restore that key that you used to sign that zone. You could always start signing with a new key, but some stuff might break when you introduce a new key without doing the proper procedures. So that is why it's recommended to do backups of your keys in order to restore your production site. And you can always add more repository, because you see here the dots. Just use the same set of configuration options for the next HSM that you want to use. In the common part, you can specify the logging. And currently we only support syslog, but in the future we might introduce some other way of logging, for instance, writing to a file, whatever you can think of. But then also you have the facility if you want to use if you want to log to different parts of syslog. Then we have the 2 parts for where you specify where OpenDNSSEC can find your CASP file, and also where it can find the zone list. These are just standard paths that we give you when you install it, but you can always, if you just run this for the first time, then you don't have to touch this, but you might want to change the paths to somewhere else and perhaps in your home directory, depending on how you set up your system. And the ZOMfetch file is an optional part of the configuration. If you do specify this file, then OpenDNSSEC will fetch all of your zones that you have specified in the zone list using AXFR. So you cannot fetch only a subset of your zones. Either you fetch all of them, or you don't fetch anything. You just assume that they are available as a zone, as a file on disk. And for the enforcer, if you don't want to run as root, for instance, then you can specify that you want to drop the privileges to a particular user and a group. And the same thing goes for the other components as well. And in this case, we specify a SQLite database where OpenDNSSEC can create its internal database. So you just give a path where OpenDNSSEC can create the database. But if you run with MySQL, then you write the host, port, and password, so we can connect to the MySQL database and create the internal structures for OpenDNSSEC. And then we have one port. Oh, sorry about the ending tag for enforcer. It shouldn't be here because we have it down here. So you just ignore that part. But we have the interval, and the reason why we have an interval here in the enforcer is because the enforcer is a daemon that runs. And in this case, every hour it checks whether your configuration has changed or if your keys needs to be rolled. So it checks on. So each hour it checks whether a key should be introduced in your zone, if a new one should be rolled, etc. So you should change this value depending on how often you want the system to update your policies for the designer engine. But 1 hour should be okay. The next two parts are optional, and you can specify that you want manual key generation. And I think this is a special case. For instance, we have the manual key generation because we have pre-generated keys for 10 years, for instance. And the reason why we want to pre-generate keys was because that was the backup solution for our HSM. You had to create keys for 10 years, and then you copy all of them over to the other HSM. And then you know for sure that you have the exactly same keys on both of the systems. But you want to say to OpenDNSSEC it shouldn't create new keys. And what happens then is that in 10 years, it will say, I've run out of keys. You have to give me a new key store where I can create new keys, or you have, as a user, have to generate more keys for it. So this is just a safety measure that makes sure that if you have pre-generated keys, that OpenDNSSEC won't generate more keys for you when your pool of keys runs out. Then we have a long delegation signer submit command. And this is if you want to hook into your EPP software and send up the DS record up to us. But it doesn't need to be EPP, it can be whatever script that you want to run. For instance, we have a script where you send the DS record or DNS key using email, for instance, if you want to send it to the system administrator. But we have the EPP client, as we said, so all it takes is the DNS key RR set and send it on the standard input to that. So if you want to integrate the OpenDNSSEC into your EPP environment, then you just provide a command where you can parse the standard input for the DNS key resource records, and then you have to convert the records over to DS records, which you then can send up to .se. And the reason why we send out DNS key and not DS is because some registries require you to send DNS key and not DS records. So this is just so that OpenDNSSEC can work with both options. And in the signer, we have the same thing again with the privileges. But now we also specify a working directory, because OpenDNSSEC, as I said, have up to 5 times the zone size because we handle reuse signatures, we have done sorting and secking, etc. But you also say how many workers you want to use, and it's recommended to have, like for instance, 1 more than the number of cores that you have on your system. And this is how many zones OpenDNSSEC can handle at once, but it's perfectly fine to have 100 zones, even though you only have 1 worker. But then you just work on 1 zone at a time. And when you have 8 workers, you can work on 8 zones at a time and signing them. And finally, in the signer, we also have the notify command. And this will be called whenever a zone is signed. So you can call your name server to reload your zone file. So for instance, if you updated the signatures or so whatever happens to the signed zone file, it will notify your favorite name server or script that you use to do something about this zone. And probably is to reload and have serve this zone instead of the previous zone. And the final part in conf XML is the auditor. And basically the same stuff as with the signer, with the privileges. And it also has its own working directory. But I think the default is the same working directory as the signer. You could split them up if you have different privileges, but it shouldn't matter to have them in the same working directory. And the reason why the auditor needs a working directory is because it's also do its own sorting when it wants to compare if we lost any information in the zone, or if we want to verify that all the signatures. But it also keeps track of the keys over time. So it will give you a notification if, hey, OpenDNSSEC hasn't rolled its keys. Is something wrong? Because in the policy you had said that the keys should be rolled each month, but now it's been 1.5 months since the key was rolled. Any questions about the conf XML? I think it's fairly straightforward on that one. But now it gets a little bit more complicated when we jump into the policy. But we have the same stuff in the beginning. Just some information about who edited the zone file or the CASP XML the latest. But here essentially we have all the information that we want to have for the policy. But it's divided up into different parts. We have one part about the signatures, another part about the Nsec and Nsec 3s, one part about your keys, some information about your zone, and also about your parent. And the information that you put in the zone and the parent has to do with the key rollovers, because we want to do key rollovers as fast as possible, but you can't do it too fast because then DNSSEC might break down. So you have to input, for instance, TTLs, how fast your zone is distributed, etc. Then we know the fastest time we can do a key rollover without breaking DNSSEC. Because for instance, now at .sc with the old solution, I think we kept the keys for 1 month, but it would be just sufficient to keep the keys for 1 day after a key rollover. So this is just to save space in your zone and also have less response sizes in your DNS queries. And before I jump forward, you can also add multiple policies, as you see down here. So just copy the entire block, rename it to a different policy, and then update the figures that you want to have differently in this policy. So as you see, we are really in details about how to do signing, but that was the thing that was powerful with OpenDNSSEC, that you could modify it in the way that you wanted it. But we do provide the default policy for you. So if you just want to start them up and running right away, then just use the default policy and don't think about it. But you should have a look on it because it do affect how your system performs and how often you roll keys. So I'll try to explain this, how we handle the signatures, because there are different parts that you have to think of. I think I should start to try explaining how the keys or the signatures are generated. So we have the picture down to the left. And the sign-in time is the time when we start signing the resource records in your zone. So that's the start point. But a signature is valid from one time, from the inception time to the expiration time. So the first thing you have to think of is the inception offset. And the inception offset makes your signature to be valid before now, which means that if the clocks on the different servers are not synchronized, they might differ on, for instance, 10 minutes. Then there could be some problem that you set the signature to be valid from now, but the system that's going to verify your signature think it's, for instance, 10 minutes. It's 10 minutes after this server, so that means that the signatures, or the validation of the signature will fail. And that is why you want to backdate the signature. I think you can find it here. So in this case, it's only backdated, is it 5 minutes? But you might, for instance, it doesn't matter if you set it up to 2 hours, 3 hours. The next thing you want to know is when should the signature expire? And that is what you specify in the validity. And you can specify it differently. You can have one validity for your Nsecs, that's the denial, and the rest of the zone will get the default value that is specified here. And I think the reason why we have split it up in 2 different parts was because we as a TLD had some requirements on us from our slave server operators to set the validity on Nsecs higher so they don't get too many changes in the zone, because I think most of our signatures will be on Nsecs, and if we create the signatures too often, then they will get higher traffic, and they didn't wanted that. But we still wanted to have a lower value on the rest of the zone for the information that we were authoritative for. But you probably will have the same dates on this. So then you have that validity period is what you see down here. But you can also add something that's called jitter. And jitter is something that you can use if you want to spread the expiration time a little bit, so that all the signatures don't expire at the same time. So for instance, if you have a large zone and then you start generating your signatures right now, and you're generating, let's say, 10,000 signatures, then you might want to add a little bit so they don't expire at the same time, and then you can use this jitter value. In this case, it's 12 hours. And the thing OpenDNSSEC does is it takes the 7 days and then adds plus minus 12 hours, a random selected value. So your signature will be valid somewhere between 6 and 8 days. And thus, your signature will not expire at the same time, and you will probably save some resources on your server. But that's only required if you have a lot of signatures to create. But if you like, you can just set this to 0 if you don't want to use this functionality. Another thing that you can do is to reuse signatures, because if you always throw away the signatures and create new ones, you also get some extra computing powers that you need to add. And that is why it's a good idea to reuse signatures. But you don't want to reuse them too long, because then it might be a case where you're too close to the expiration date of the signature. So that is why you can set, well, first of all, we have the resign. And if you see the picture down here, the resign period is how often OpenDNSSEC should check whether or not a signature is about to expire and if it should be refreshed. So in this case, it's every second hour the signer engine will go through your zone and see, okay, this signature should be updated, so just create a new signature for it. But the decision on whether or not to recreate or reuse a signature is based on this refresh timestamp. And we know the expiration time because that's what we calculated in the previous step. So for instance, let's say that we now see that this signature is valid for 5 more days, but we have said, or let's say that in this case we reuse signatures up until they are about to expire within 3 days. So we'll reuse it, but when we see that the signatures only have 3 days left on their validity period, then we do a decision to recreate the signature. So it was a little bit complicated, but hopefully you will practice on this tomorrow, and maybe it will get a little bit more clearer on how everything goes together. Any questions about this part? No. And the next part of your policy is whether you should use Nsec or Nsec 3. If you just want to use Nsec, then just write Nsec and not this entire blob of Nsec 3 information. But if you do want to use Nsec 3, then you have to specify these parts. And then you have an optional part, the opt-out, which means that you only sign. So the opt-out is only useful for those zones that have many delegations, because then you create less number of signatures, because you only create Nsec 3 records for the information that you are authority for. And in Nsec, you also use salts in order to hide the information that you have in your zone. And this is so that you cannot just as easily create rainbow tables to create some collisions. So this value is that you specify that each 100 day you should recreate the salt value, because then you think that, okay, within 100 days someone might have created a complete rainbow table using this salt that you have in your zone together with all the possible combinations. So it's recommended that you replace the salt value after a period of time. And then some information about the hash. Currently there is only one version of the algorithm. It's SHA-1. So this is not one is not equal to the SHA-1, the one in the SHA-1, but it's the algorithm number that's has been specified by from ITF. And you can also apply the hash, or you can do multiple hashes or iterations on doing the hashes on your domain names. And in this case, you do it 5 times, but you can do it 0 times, you can do it 100 times, you can set whatever value you want. But this will impact the performance on those who will do validation, but also on your name servers. Because your name servers have to create or find out which Nsec 3 records it should return to the resolver. In order to know that, it has to do some calculations, and then it has to do this 5 times iterations in order to know what Nsec 3 records to return. But this is only when you do when you return NX domain answers back to the resolver. But there are some good papers to see how the performance are on your name servers, depending on how many iterations you have when you run Nsec 3. I think it's available on NL NetLab's webpage if you want to see it. And then you also specify the length for your salt value. Yeah, and as I said, skip this if you only want to use Nsec. Then you just write the Nsec tag and then you're finished. Because Nsec doesn't need any information on how to do it. And when we're talking about the keys, we have some common parts for the case and status case, and those you can find here. And first of all, you can specify the TTL for the DNS key resource records that will be created and added to your zone. You can also add some safety margins on top of the, because we do some calculations based on the values that you have. We'll show we have those values in the zone and the parent. These values will be used to calculate when a key should be rolled and when a key can be removed from the zone. But to be safe, you can add some safety margins on top of this. So it's, for instance, in this case, we keep the key 1 hour extra just to be safe. And also that we pre-publish the key 1 extra hour to be safe, so we don't just be on the margins on when it's safe to roll the keys. So we should always extend it a little bit more than the optimal value of doing key rollovers. And then you can also have the option to share the keys. And sharing the keys means that if you have 10 zones, then those 10 zones will have the same key pairs for the status case and the case. But if you don't use this, then all the zones that use this policy will create its own keys. So all the zones will have their own keys. And if you have limited space in your HSMs, then you might want to remove the old keys that are not used anymore. Either you can do it manually, or you can let OpenDNSSEC do it automatically for you. And in this case, if we remove the comments, then OpenDNSSEC will remove keys that are not used after 14 days for you. But there are also a command line utility where you can specify that remove all keys that are not used. The part about the case K. Yeah?
Can I just jump in there quickly on those keys?
Yeah.
So you have 10,000 domains, and you're not sharing keys. Are you generating 10,000 keys every 7 days or whatever your time period is?
Mm.
So what is the negative aspects of using a single key for 10,000 domains?
First, there are different things that you have to think of. The first thing is that you have limited space, and it also takes time to generate the keys, because I think it takes, could be 1.5 seconds, perhaps, or 1 second to generate a 2048-bit key. So then you have 10,000 seconds to just generate the keys. But then you also have to store them somewhere. And if you have some HSM vendors have limitations on the number of keys that you can store, but the others also require you to pay a license fee for the amount of keys that you store in the HSM. The other thing might be that some argue that, or if you use a key too much, then you will reveal too much information about the private key material. So if you have used, so then you're using, if you share the key between 10,000 keys, then you're revealing 10,000 more about the private key, because each time you sign some information, you give out some little bit hint of how the key is constructed. But that's just theoretical, and you can compare it with, for instance, let's say a large TLD for us. For instance, we have, what is it? How many resource records do we have? Is it 2 million, Patrick? 2 million resource records in the .se zone? Yeah. So if you compare that with 2 million resource records, can you say 1 million? And you have 10,000 zones with 100 resource records in each of them. Then it's just comparable with a TLD, and they don't have any problem sharing or using one key. And we do rollovers, I think it was status case each month and case K once a year. But I think there are some recommendations that you can use them longer, and when we specify the times, rollover times, we were the first one to do it in the world, and then most people have just followed what we did. But there's currently no good study on how often you actually should roll your keys. And there also been some. Patrick has written a paper, for instance, that there might be some problem if you roll the case that you will get increased load on your name service because there are some, for instance, bug. Some of the resolvers are really hard to retry and verify stuff if they don't have the correct keys in them. So I think it's safe to share the keys between zones. But some argue that you shouldn't share keys. But currently there aren't no best current practice, but from my point of view it's perfectly okay to share the keys. And then you have your case K, and now you see that we specify the bit length if you're going to use an RSA. So in this case, I think it's RSA SHA-1 Nsec 3 is this algorithm called. And 5 is for RSA SHA-1. Then there's also 9, 10, I think, and 8. But you can find these values either in the documentation or online on different places. I think IANA has a text file which specifies what algorithms you can use. But we currently don't support a DSA, so we only support RSA. RSA SHA-1, 256, and 512. And then you have how often your keys should be rolled. It's once a year. But OpenDNSSEC won't do it fully automatically for you because you have to upload the public key before we can complete the key rollover. But I will show you a command how you do the key rollovers in OpenDNSSEC. And you will also try it tomorrow to see how the key rollovers are done. Then you also specify your HSM or your repository. So this is not the token label. This is the thing that you wrote in your conf XML, the name of the repository. So those can be separate from each other. And you might also want to use standby keys. And a standby key is actually not so necessary, but if you want to speed up an emergency key rollover without having to pre-publish the keys, wait for 2 days, and then make it active. If you have a standby key, then you already pre-publish the key that you can quickly switch over to. But in most cases, you can wait 2 days, so you would save space in your DNS queries if you don't have standby keys. But if you want to be able to roll and do emergency key rollovers really fast, then you should have a standby key. And if you jump over to the ZS case, it's the same thing. I think you can specify the same things, yes. And it should be 1024, not 25. Sorry about that. And also the lifetime, in this case, 30 days. But you can specify another repository, but I think we're using the same. Yeah. So in this case, we're using the same repository, but you can, if you have higher security requirements for your case, for instance, you want to use soft HSM for your ZSK, but you might want to use a smart card for your case. Then you just can separate them in this policy. But you can also add the manual rollover tag, and that means that OpenDNSSEC won't roll the key automatically for you. And you can use this. This is a special case if you want to specify that the keys should be rolled exactly the first of each month. Then you just set up a cron job, which does it for you, and then call a special command to OpenDNSSEC to do a key rollover. But if you don't have the manual rollover, then OpenDNSSEC will do the key rollover accordingly to this lifetime. And as we said, even if you write 1 month, it's converted over to 31 days. So will drift over time when we do the rollovers. And it might be useful to have manual rollovers if you want to do the rollovers on when you have working days, so that you know that you have people on site. That might be a good reason why you want to have manual rollovers and just set up a cron job to do it for you. But you shouldn't. Anything shouldn't go wrong. So, just for precaution, that you can use manual rollovers. And finally, we have one part more actually, but then you specify some information about your zone, and parts of these are used for OpenDNSSEC in order to calculate how fast it can do the key rollovers, because you know the propagation delay on how quickly you can get your zone out on the name servers. You also know what SOA values you want to use. You have the TTL and the minimum. But then you also want to specify the type of serial number you want to use. Either you want OpenDNSSEC to just set a timestamp, just ignore the incoming value from the unsigned zone. Or if you have for instance, a date counter, take whatever is in the, or if you use counter, then you just take whatever value you have in the unsigned zone, keep updating it, but if you get a new unsigned zone with a higher value, then take that one. So you always have the highest value of SOA serial that you send out. But you can also have keep, which means that you just keep the unsigned serial number from the incoming zone. But OpenDNSSEC will only be able to sign the zone if you update the SOA serial at the regular. So for instance, if you update your zones every second hour, then you also increase the SOA serial number. And once you do that, then OpenDNSSEC can update the signatures for you. But if you have specified keep, you place the zone only one time, then OpenDNSSEC can only sign it once for you. It cannot do it afterwards, because we can't send out a zone file which we can't update the SOA serial number for. But we have those 4 different modes that you can use. Then we have some information about the parent. And this has to do with the case K rollovers, because we want to know how quickly we can get up the DS records, and know how fast will it go from .se out to its slave servers. What TTLs do we have on the DS records, and also about the expiry information or the minimum and TTL for the SOA record of the parent. And this is for negative caching, if there are some negative caches in the resolvers out on the internet. So you know that they have expired before we start doing rollovers, introducing new keys. But these values you can find out from us. But if you don't know them, then you have to do an estimation and set some higher values. It's a little bit tricky to tell you how all these values are calculated into the key rollovers, but you can read some draft if you want to know the exact formula on how key rollovers are done. But it's just simpler to just write down the values and then know that OpenDNSSEC does what it should for you. And then we have one part for the auditing, because the signer engine doesn't call the auditor unless you have specified the audit tag in your policy. So if you leave this out, then no auditing is done on this zone that's using this policy. And you can also specify a partial, because the auditor is a little bit slow if you're going to audit a large zone, for instance, .se. I think it took 1 hour to just do auditing. But if you specify partial, then it took 5 minutes instead of 1 hour in our case. And I think the partial will only check that we don't, I think it's specified in the documentation. What's the difference between those two? And yes. Okay, so we have the configuration and we have the CASP, the policy. So you have to remember that you can have multiple policies for multiple zones, but you can also have one policy for 100 zones, so you can have 10 zones sharing one policy, then you have 2 zones sharing another policy, so it's up to you how you combine all of this. But in order to specify this, you have to go into the zone list, and that is where you specify what zones you're going to sign and what policy you're going to use, and where the unsigned and signed zone file are going to be placed, or be found and placed. So it looks like this. You write your zone name. You have the policy. In this case, the policy name default, but you can, if you have another policy, just write in that policy name. This part is just for internal communication from the CASP enforcer to the signer. So you don't have to create this file. This will be automatically created by OpenDNSSEC. But the reason why we're exposing this variable is because if you want to replace some of the components, then you can find the information where to find the files by looking in this zone list. So for instance, if you want to have OpenDNSSEC on top of bind as a signer engine or whatever you want to use. Then you have some adapters, but currently we only support file in and file out, with a special case of AXFR which fetches the zone file and places it on this input path. But in the future, we're hoping to add stuff like AXFR, IXFR, etc., or a database connection, or where to find the zone file. So you have multiple inputs and multiple outputs adapters.
Does it support PC for AXFR?
Yeah. So let's see if I have it. But I can show you, actually. I don't have it in this presentation, but I can, either you can read in the documentation or, so you specify the IP addresses and the port numbers, the TSIG secret that you're going to use. This is the master file, we should call it that. This is where the main information about the zones are available. But you also have the information in the CASP database that we set up when we start using OpenDNSSEC. So you can just give a command line add zone, is the command ODSK semi-util add zone, and then your zone name. And this will write, it will add both to the database, but also write out the information to this zone list. So you don't have to do manual editing of this zone file. There are commands for you to add new zones that you want to sign. But you can write parse or create the zone lists from your own tools if you want to do that. Yeah, and the ZOMfetch XML is available online if you want to read more about that one. And yeah, so that was the configuration. There's a lot of values that you have to configure, but you only have to do this once and then just adding zones using the command line utilities. So you have to think a lot in the beginning, but during the operations, you only have to use some simple commands to maintain the system. Any more questions about the configuration? But you'll try this several times during tomorrow and on Thursday. Yep.
Regarding the input and output files you had in when it loads that input file, does it write to it at all? Like the original file, the unsigned zone, it doesn't write to that?
Nope.
So if you...
We only have to read from.
If you updated that file 6 hours later...
then you have to tell OpenDNSSEC that you have updated that file, because otherwise we'll just maintain the signatures. So whenever you update this file, you have to tell OpenDNSSEC sign, ODS signer sign that zone, then it will refetch the unsigned zone file and then check what has changed and apply a new signature on top of that. Otherwise it will just run and maintain the signatures for you. Yeah, so it's rolling the serial numbers.
So does it matter what the serial number is in the input file then?
It do matters if you have the keep options, which means that you keep the unsigned serial number. And then we check against the unsigned SOA serial number to see if it's been updated. If it has, then we can output more.
If you're letting OpenDNSSEC manage the serial number, then it doesn't matter what your serial number is that you generate.
Exactly. But I think it's, if you use, for instance, counter, then we use your serial number as the start value. But the Unix time is just a replace because that's the timestamp. And I can't exactly know how we do with the date counter. If we have some data, I think I have to look into the code exactly how the semantics is for the handling of the different SOA serials.